Our first section in chapter 8 is the Pythagorean Theorem, which you guys should already have some practice with. So the Pythagorean Theorem says that if you're given a right triangle, then a squared plus b squared equals c squared, where a is the legs, b is a leg, and c is the hypotenuse. The hypotenuse is always across from the right angle. That's how you determine which one the hypotenuse is. And then we have the converse, which says that if you figure out that a squared plus b squared equals c squared, then the triangle is going to be a right triangle. And some theorems that go with that are if a squared plus b squared is less than c squared, then triangle ABC is obtuse. So if you have a bigger hypotenuse, then it's going to be obtuse. And then the converse of that would be a squared plus b squared is greater than c squared, then triangle ABC is acute. So if c squared is less than or smaller, then it would be acute. So we're going to take a look at a few examples. Our first example, we have our right angle here. So I know that this has to be my hypotenuse. So this is going to be C, and then A and B you can interchange. Doesn't matter because they're both the legs. So I'm just going to write out the formula and then substitute in my numbers that I have. So A is 7, B is 9, and I'm trying to figure out what C is. 7 times 7 is 49, plus 9 times 9 is 81, equals C squared. And then 49 plus 81 is 130, equals C squared. The opposite of squaring something is you take the square root. And now we can't simplify this any further, can't break it down. So we're going to leave it as C equals the square root of 130. Example B is a little bit different because we have, again, a right triangle, but now we're given our hypotenuse. So we're given C, and then we have to find one of the legs. So we have to just pay attention to where we're plugging things in. So I've got a squared plus b squared equals c squared. A is going to be 3 because it's a leg. B is also a leg, so that's x. And then c is 5, that's my hypotenuse. 3 times 3 is 9 plus x squared. I'm still trying to figure that out. And then 5 times 5 is 25. We want to get x squared alone, so I'm going to subtract 9 on both sides. I get x squared equals 16. Then I will take the square root of both sides, and the square root of 16 comes out a whole number, and it's 4. So x equals 4. So that means that this side length right here is 4. Now we have to classify each triangle as acute, right, or obtuse. So remember, if c squared is greater than a squared plus b squared, it's obtuse. If c squared is less than a squared plus b squared, then it's obtuse. So a and b are going to be my smaller ones, and c is always going to be my larger number because no matter what, the hypotenuse has to be the longest side. So we're going to set it up how we did the last problem, so a squared plus b squared, and what we're going to leave is a blank here because we don't know if it's equal, greater than, or less than. So then we're going to plug in our numbers. So we've got 6 squared plus 11 squared. Still trying to figure this out. And 14 squared. 6 squared, 6 times 6 is 36, plus 121. Still trying to figure out if they're equal or not. And then 14 times 14 is 196. If we add these two together, we get 157. And then you've got a box, and then 196. And we're trying to figure out c squared if it's bigger or less than. So c squared is bigger. So since it's bigger, since this side is bigger where the c is, that would make it obtuse. Our last example is a word problem. With the word problems, you have to draw a picture. So our word problem says a window cleaner leans a 13-foot ladder against a building. The base of the ladder is 5 feet from the building. How high on the building does the ladder reach? So I'm just going to start with my first thing. I've got a window cleaner leaning a 13-foot ladder against a building. So here's my building. And then I've got this ladder here. Because it's leaning against the building. And this is 13 feet. Then it says the base of the ladder, so this is the base of the ladder, is 5 feet from the building. So it's 5 feet here away from the building. And then we are trying to say how high on the building does the ladder reach. So this is what we're trying to figure out up here. So that means I have to figure out the height for this side. So again, now if we look at my triangle, if I pull this out into just a normal triangle, I've got 13, 5, and x. So I have my 13 is my c, my hypotenuse, so I'm going to plug into a squared plus b squared equals c squared. So my A can be x and B can be 5. So x squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. Subtract from 25. You get x squared equals 144. Opposite of squaring is you take the square root, and then we get x equals 12 feet. So the ladder reaches 12 feet high.